The new images from the James Webb Telescope have left researchers in a state of shock. Instead of deepening our knowledge of the universe, the images reveal a disturbing fact. Our physical understanding is not sufficient to explain the nature of the early cosmos. Where the Big Bang Theory reaches its limits, new hypotheses of origin have to be applied. But how could the universe have been formed in detail, and why does the new discovery push even the most experienced astronomers to their limits? Stay tuned and find out together with us. The Big Bang. Before we go into more detail about this revolutionary, sensational discovery, let's refresh our memory for a moment. So, what is behind the oft-quoted concept of the Big Bang, which is known to describe the creation of the universe? Well, contrary to the first assumption and some representations, it was not a brute explosion into an existing space. It was rather the space itself which originated about 13.8 billion years ago, together with all matter and time from an original singularity. Once again, a brief reminder. In the world of physics and astronomy, the designation singularity describes places where gravity is so extreme that the curvature of space-time diverges, or in other words, is infinite. But how can we be sure today, so many billions of years after the birth of the universe, that our cosmic home was formed within the framework of such a process? Concerning this, experts refer to a characteristic which was inherent in the universe already since the very beginning of its existence. It expands unchecked. But also in this case, it's necessary to consider one thing. The cosmos does not expand into an existing space. It's the space which becomes bigger incessantly. Now it's possible for experts to consider the expansion of the cosmos backwards and to calculate back to that point which embodies the origin of the universe. As an outstanding proof of the correctness of the Big Bang Theory, the proof of the cosmic microwave background radiation is listed, a nearly isotropic radiation that fills the entire universe and represents a relic from the early days of the cosmos. At this point, it should be mentioned, however, that the individual Big Bang theories explicitly do not deal with the actual birth of the universe, but with the immediate phase afterwards. In detail, we move here in an order of magnitude between a so-called Planck time, that is, about 10 to the power of minus 43 seconds and 400,000 years after the Big Bang. And even though we have no idea so far what the cosmic state was like before the mysterious Planck time, the Big Bang theory has an unshakable position within the standard model of cosmology. Things get particularly tricky, therefore, when researchers uncover something that simply cannot be reconciled with our current theories and that even provides reason to question everything we think we know about the origin of the universe. Impossible galaxies. If one follows exactly those common theses, then the first stars began about 200 to 300 million years after the Big Bang to shine and to drive away the Dark Age. When the first glistening bright celestial bodies came together to full-grown galaxies, and how fast these grew up is still completely uncertain. A first clue to the solution of this galactic riddle was provided by some of the first James Webb images. As early as July 2022, experts announced that the Space Telescope had detected a number of galaxies, some of which already existed 300 million years after the formation of the universe. Compared to the structures that blossomed in the following millions of years, however, these were still significantly smaller and lower in mass. A scheme which agrees perfectly with the official models of the researchers, because after all, the density of the matter in the young universe was simply not sufficient to form galaxies of the size of the Milky Way. Or was it? What began as the discovery of 6 inconspicuous, reddish shimmering points of light was ultimately to trigger one of the greatest astronomical crises of the recent past. But what had happened? Although the newly discovered galaxies are of comparable age to the previous record holders, they are almost as massive as our home galaxy is today. That astronomical research is now richer by a tantalizing mystery is thanks to the team led by Ivo Lebay of Swinburne University of Technology in Melbourne. After scrutinizing a series of images taken by the near-infrared camera, NIRCam, the experts finally stumbled upon the aforementioned light sources. With the help of the redshift, the scientists calculated that the light of those objects needed over 13 billion years in order to graze our terrestrial eye. Consequently, we are dealing with structures that already existed 500 to 700 million years after the Big Bang. The evaluation of the characteristics provided again the realization that Webb had caught 6 very early galaxies on picture, and indeed 6 galaxies which were so massive that they contradict the usual assumptions of cosmology. Astronomical dead end. Instead of encountering the expected galactic midgets, Webb identified structures that were nearly as massive as the Milky Way despite their early formation date. If one follows the analysis of the collected data, the gravitationally bound star collections already possessed more than 10 billion solar masses at that time. One of them might even have broken the mark of 100 billion solar masses. The problem? According to our current knowledge, this was simply not possible. A thought which also drove through the heads of scientists why they believed at first to have made a mistake. However, this suspicion could not be confirmed in the context of detailed follow-up investigations. The only remaining hope of the experts consists now in the fact that the 6 objects do not embody in truth by far the most massive galaxies of the early time, but other formations, as for instance black holes, which lie hidden behind an impenetrable dust wall. But if you think that this solves the mystery, you're wrong. Even in this case, there would have been much more stellar mass in the early universe than assumed so far. Since shortly after the Big Bang, not enough normal matter existed to form so many stars in such a short period of time. The detected objects are in stark contradiction to practically all common cosmological theories. Even if only one galaxy turns out to be real, this would go beyond the limits of our previous assumptions. In order to be able to explain the existence of the structures, the density of matter in the early cosmos would have to have been up to 5 times larger than assumed so far. The other, not less mysterious explanation approach is based on the fact that the galaxies developed in a way which is completely unknown to us thus far. The Big Bang debate. This and further discoveries provide for the fact that at present, more and more researchers turn away from the Big Bang theory. Many astronomers who show a more alternative point of view complain about the fact that they are not listened to in the scientific journals. What's more, he who expresses his doubts about the existing theses is often regarded even as crazy. However, one thing is undisputed. Experts who still hold on to the Big Bang are confronted again and again with questions to which there are no clear answers. These include in particular questions of why and how. How can it be that 13.8 billion years ago, something came into being out of literally nothing? Can anything form out of nothing at all? And was there a compelling trigger for this, or was it merely a coincidence? In this regard, Stephen Hawking pointed out that time itself began only with the Big Bang. Consequently, this process could not have been triggered by something or someone. No less controversial is the question of the uniform radiation and density in the cosmos. No matter in which direction or in which distances we look, on a large scale, similar densities and distributions of galaxies, nebulae, and radiation exist everywhere. The conservative experts explain this with cosmic inflation, while other experts take up this assumption and spin it a bit further. According to chaotic inflation, it is conceivable that this process came to a standstill only in some bubble-shaped subranges and continues otherwise eternally. This also means that a multiplicity of sub-universes is formed in the bubbles, whereby each cosmic world contains its individual physical laws. Against this background, therefore, a fundamental question arises. What if the cosmos does not embody the Great Whole at all? What's more, if another universe already existed before ours, in that case, the Big Bang would have to turn into a big bounce. Alternative theories. If we follow this theory, words like beginning and end are moot in the cosmic context. What we commonly refer to as the Big Bang was in fact nothing more than a cyclical transition. As soon as one universe dies, a new one grows out of it. According to this, the universe, which is part of a multidimensional structure within this model, is subject to an eternal rhythm of collapse and resurrection. However, this is by far not the only explanation approach which has led the field further apart from the Big Bang theory. As early as 1955, for example, an article appeared in NASA's Cosmic Times arguing that there never was a Big Bang because the universe has existed for an infinitely long time. The expansion of the cosmos is also non-existent. The constant formation of matter merely gives the impression that the universe is constantly expanding. The equally most exciting and most controversial theory of origin comes again from the world of quantum physics and string theory. Supposedly, experiments showed that the universe and everything in it, in fact, does not exist at all. In simple terms, what we perceive as the visible universe is nothing more than a flat hologram projected onto a sphere. Consequently, it's possible that we together in our reality are the result of a superordinate simulation. What at first sounds like a plot of a wacky science fiction flick can actually be reconciled with the so-called Kardashev scale. This categorization indicates how far a civilization is developed on the basis of its energy use. If there really is a civilization of Type 3, which is able to use the total power of a full-grown galaxy, it could have succeeded in creating a perfect simulation with the help of a so-called Matryoshka brain. But whether we would really wish to know the truth in such a case is another matter entirely. And with that, thanks for watching. Feel free to subscribe and leave us a thumbs up if you liked our video. Now, we're curious about your opinion. Do you still believe in the Big Bang Theory? Or do the alternate explanations seem more plausible to you?
มี